Hey guys, and welcome back to a new video. In this video, I will show you how you can make a dictionary app while sticking to the clean architecture guidelines. So many people actually asked me to make another of these videos about making an app with clean architecture, and especially to make an app with clean architecture and caching. So that is what we will do today and what you will learn today. So it's a very simple app. I will show you that in a moment. That basically has the option to get dictionary entries, so just info regarding a specific word from a remote API, and then it will save that in a local database to cache it, so we can also access these words that we accessed in the past, even if we are offline, so if we don't have internet connection. So let's actually take a look here how this looks like in the end, what we will build here. You can see it's very simple. It's just a search field here, but if we actually enter something in that search field, let's say we search for Android in the dictionary, then we actually get a dictionary entry here. So we get the word, obviously, how it's pronounced, and just some info about that word. Now, if we enter another word, like morning, for example, then we get information about morning. And if there are multiple entries in the dictionary for a specific word, like probably for bank, then we actually get multiple entries of this bank, because a bank could mean something else depending on the context. So yeah, it will actually consider that. And now the cool thing, as I said, if we simply enable airplane mode here, so we don't have internet connection, and we close our app and reopen it here, then you will notice if we search for something else like Apple, that we will get a toast here, a snack bar, that we couldn't reach the server because we don't have internet connection. However, if we search for something that we already searched for, like Android, we actually get the information because it's contained in our local cache. And the same will happen for bank. So if we search for that, we will get the bank information. And we also get the snack bar because, yeah, we still don't have internet connection to refresh that. So let's next actually take a look at the API that we will use for this. That is the free dictionary API. So you don't need any form of authentication for that. You can just use it. This is the website, so dictionaryapi.dev. You can try around there. You can also enter some words here. You can see a search for morning, and if we press enter here, then we simply get a JSON response. And in the end, we will just do this, but in our app. So you can see that will be the actual URL that we will then use in our app, api.dictionaryapi.dev, and then with the corresponding URL afterwards. So all you really need to do before jumping into this video is to check out my GitHub repository down below, because there you will find the dependencies that we will use for this project. So you can just pull this from my GitHub, or you can download it as a zip and open in your Android Studio, or you just copy over the dependencies into your build.gradle file, which I will quickly go through here, so you actually know what we're dealing with and the dependencies that I actually use for what we will use these. So you can see the compose dependencies, which is just the view model dependencies. So yeah, we will obviously stick to MVVM and clean architecture here, and for that we need view models. Coroutines, I think that's obvious for network calls and for actually accessing our database in an asynchronous fashion. Lifecycle scope, stagger hilt, we will use that for dependency injection. Retrofit for the actual API calls. Room for caching our actual dictionary entries. And Kotlin extension and coroutine support for Room, so that we can actually use coroutines in combination with Room. So without further ado, let's actually jump right into the project and start with setting up our project structure, because I usually just like to start with that when I do these videos, because it gives you a good understanding of the general structure and project we build, and which layers we have and which features we have and why it's actually structured that way. So first of all, if you're new to clean architecture, it's basically something a type of architecture we build upon an existing architecture like MVVM. So usually in MVVM, we have our UI layer. So in Android, that's the activities, fragments, or if we use Jetpack Compose like we do here, then that's our composables. Then we have our view models that contain our business logic, and our data layer, usually in form of some repositories that actually make the API calls or calls to our local database. Here in clean architecture, that's actually quite similar, but we have an additional layer, which are the so-called use cases. These are located in the so-called domain layer. So in the domain layer, it's actually the shared layer between data and UI. So it will basically contain the business rules and the business logic of our app. And when we actually get to that point of creating these use cases, then it will get clearer why we have these and why that's actually useful. When I actually create a clean architecture project, I usually structure that by features, and these features I structure by layer. So what that means is a single feature in your app would, for example, usually just be a set of screens that somehow belong together. So if you have a social media app, then that could be everything regarding profiles. So one feature could be the profile feature that contains the display profile screen. It contains the edit profile screen, maybe some kind of logout screen, I don't know. Something that's related to profiles. Then you could also have some kind of post feature, which is just a set of screens that deals with posts, like a post list feature or post list screen rather, or a post detail screen, stuff like that. And I have these features as the root of our project. So what we will do is, in this app, because it's so simple, we just have a single feature, but I just want to show you right away how you should do it in a real app. So we will create a new package here in our root package called feature dictionary, for example. Let's create that. And then in this feature, we can now create our different layers that we have. So that is presentation, domain, and data. Presentation is basically UI, so it contains our composables here. Domain contains, as I said, the use cases and our actual entities that are shared between UI and data. And the data package will then contain our repository implementations. It will contain our room database classes and our retrofit API interface. So let's actually start to create our presentation layer here. I will leave all of these empty for now, just to have a general structure. We will then have another package in the feature dictionary, which is called domain. And inside of that, we will have a use case package for use cases. We will have a repository package in the domain package. And that will actually only contain the definitions of our repositories, but I will get to this later. We will have another package for our models. So a model package. That's already it for the packages in the domain layer. The next layer would be the data layer. So in the feature dictionary, a new package, data.remote, for example. So we will have a data package. And inside of that data package, we have two types of data sources here in our project. On the one hand, the remote data source, which is our API, and on the other hand, the local data source, which is our room database. So we also want to have a local, and in that local package, we will have another package for our entities that we actually save in our database, so every single table. And actually in the remote package, we will also have a similar package, which we call DTO, for data transfer objects. So that is basically the Kotlin implementation of the JSON response that we get from the API. And then we will have some kind of mapper functions that takes this JSON response and maps it to a class in our actual domain layer, which we can then share with the presentation layer, which contains the view models. So that's it for our three main layers. Another package we need in the feature dictionary is a package for DI, dependency injection, which we use Dagger Hill here for. So yeah, later you will understand how that will look like. And I think one more, and that is actually in our root package. So outside of this feature dictionary, in the root package, we want to create another package called core. So in clean architecture, the core package is basically the one that contains everything that's shared between multiple features. So right now we only have one feature, and it would be totally reasonable to put the stuff from the core package inside of the feature dictionary package. However, as your project grows, you will have more features, and there will be classes you actually need in multiple features. So you actually put these classes in the core package. And here in this particular case, we will have a util package in here, because later on we will have a utility class that we will actually need throughout the whole project if we would have multiple features. So far for our project structure, let's actually start to code, and I want to start with implementing our API. We will do that in our remote package here. Right-click New Kotlin class of file, and I will call that Dictionary API. That will be an interface. Yep, I want to add that to Git. And yeah, I won't dive deep into retrofit here. I assume you know that if you're watching this rather advanced video. This will essentially just have a single function that we now define how we actually want to access our API. So read route and what that basically takes as parameters and returns. So that will essentially be a GET request because we want to get some data. And now we have to define the URL here, which is API/v2/entries/en/word in curly braces, because that will be the placeholder for the word that we actually enter. And by the way, if you want to have that dictionary in your native language, you can simply swap out this en with your language code. Of course, the API needs to support that. I tried it with German with DE, and that worked. So then you can look up for your own words in your language. I will leave it English here, and that will essentially be a suspend function, get word info. And we will have a path parameter, which is word here, and we'll just call it word, which is a string, obviously. So whatever we pass here for the parameter will be inserted here in the URL when the request is actually done. Now this function, of course, needs to return something here. It will return a JSON response that is parsed here to one of our DTO classes that we don't have yet. So let's actually first declare these classes before we can actually define the return type here. For that, we need to go to our API website and take such a word here. Let's actually, I don't know if this is the best word to demonstrate this. Maybe we search for bank. I don't know if this is even better, but we just want to copy everything that we get as a response here. We want to go back to Android Studio and right-click on DTO, new Kotlin data class file from JSON. That is a plugin that I have here. If you don't have that, you can click Control Alt and S to open your settings. You can go to plugins and then simply search for that Kotlin to JSON to Kotlin class here. Install that, and then this option will appear for you. You probably need to restart Android Studio. It will basically just take the JSON response that we got from the API and will parse that into our Kotlin classes. So the class name we want to parse that into is word info DTO. So we press enter and it will now generate quite some classes here. And we actually need to restructure that a little bit here. You can see 5 classes essentially. And this is the word info DTO that makes up the root response, basically. You can see that's nothing else than just a list of items. So we can totally remove this because we can also directly return that list of items in retrofit. And we want to call this word info DTO item just word info DTO. So we can click on that, Shift F6 to rename this, and just remove item here. Press enter, and there we go. If we open this up, you can see we have meanings, phonetics, and the rest is just strings. That is fine. Let's actually also rename these meanings and phonetics here to something like DTO. Also Shift F6, by the way. Yeah, just clicking OK here. Doing the same for phonetic, Shift F6, and appending DTO. Clicking OK. And one last time for definition. Here you can also, by the way, see these antonyms because the response wasn't optimal. So there actually weren't any antonyms, so it couldn't determine which type these had. So it just used any here, which we wouldn't like. Instead here, because I looked up a word that had antonyms, we can just use string. So I know that will work when we parse that. And I think the rest is actually fine. Let's make sure that we rename this, pressing Shift F6 again, definition DTO, clicking OK again. And I think the rest is actually good here. Okay, so now we have these classes. Let's jump back to our dictionary API and actually return that because it returns a list of word info DTO. It returns a list because, as you've seen, if we enter bank, for example, then there are multiple words that correspond to a single query, basically. So yeah, we could return multiple of these word info DTOs. Now what's next? So in clean architecture, we typically have so-called mappers when we have these DTO classes. What a mapper does is it basically takes one object and maps it to another. If we have these DTO classes, we would like to have these mappers to map such a DTO to a model of our domain layer that we will actually then show in the UI. So that should only contain the data that we actually want to show in the UI. And because we have quite some DTO classes here, we need to create such a mapper function for each of these. So let's start with the definition DTO, and we can just put this in here in the class body. And I'll just call this toDefinition. So it will just return a definition without DTO, because that's how we will call it. We will call the class in our domain layer. So let's actually create that in domain model called definition. Will be a data class. And for this particular case, it will, I think, just contain the same entries as here. So we can copy these, paste these, and I think the example is actually nullable here. Let's also make that nullable here in the DTO class. I just see that on my code that I have prepared, because it seems like some words don't have examples and then it might crash if it tries to parse that. However, let's simply return a definition now here from our model package. And we can just say return a new definition, and we just pass our values as these are. This seems a little bit unnecessary here, because we just create an object that looks exactly the same as we have here. But it's still good to stick to that in terms of consistency. Usually these model classes just contain less information, only the information we really need, because sometimes these API DTOs and API responses contain so many data fields, you don't always want to have these in your UI. Then we'll have an example here, and we will have synonyms. So far so good. Let's jump to the next layer, which is the meaning DTO. So let's also create that in our model package, just called meaning here, also a data class, and this will contain a list of definitions. Now we use the list of definitions that we have in our model package, and it will contain the part of speech, which is just a string. So then in our definition, actually meaning DTO, we can write another mapper function to meaning, returns a meaning. And we can say return meaning, the definitions is definitions, and the part of speech is part of speech. And here we get an error. Yeah, absolutely, because we actually expect definitions here being of the type of the definition we have in the domain layer. However, these definitions are of DTO. So this is now the first time we can make use of our mapper functions by simply using .map it.toDefinition. So we just go through the list and map every single item to such a definition. Let's do that one last time for our word info DTO, which is here in our model package as well. So right click a new Kotlin class called word info, data class, and let's take a look in our word info DTO here. Exactly. Actually, here we are only interested in this single phonetic, so we don't need this list of phonetic DTOs, which contains audio and text. So that's something we now don't need in the model of the domain layer. So we can simply leave that away and not pollute our UI with that. So here we can simply copy everything from word info DTO, go to word info, paste this, and remove the phonetics value. Then in word info DTO, we can say, okay, we want to have a function to word info, returns word info, and we can say return word info, meanings is equal to meanings, and origin is equal to origin, phonetic is phonetic, and word is word. And I'm not sure right now if we take a look here in word info. Yeah, you can see that's a mistake. I didn't want to use the meaning DTO, instead just the meaning. from our model package in the domain package. And we can remove the imports here, because now we actually then need to go back to word info DTO and also map these meanings. So we say that map it to meaning. And that's now everything for this mapping stuff here, at least for the DTOs. So now we basically have our UIs, our API set up. Of course, we still need to create that later, but that's not what we will do now. Instead, we will next set up our database. And for that, I will actually start with the entity, so the table that describes which fields we want to save in the table. That will be put in this entity package here in our local data source package. Right-click new class, and that will be called word info entity. Will be a data class. We annotate this with entity. And well, in the end, we save very similar things in this database as we get from our API, because we of course want to be able to display everything as usual as if we would get that from the API. So we have the word, we have the phonetic, we have the origin, which is also string, and we have the meanings, which is a list of meaning. And finally, because we're dealing with database entities in an SQL database, we also need an ID for every single entry, which we annotate with primary key. So we just make sure that we can uniquely identify each item. And then here in the body, we will also have a mapper function, which is a lot less work here for this database entity. So function to word info, so that we can also easily convert that to a normal word info of our domain layer. So word info, and that returns word info. Meanings is meanings. The word is word. Origin, and actually phonetic is phonetic. So far so good. That's it for the entity here for our database. The next thing we need to do for our database is to actually set up our DAO, our data access object, in which we will define the functions, how we access our database. So here our local package, we right-click new Kotlin class, and that will be called word info DAO. And that's actually not a class here, that is an interface that we annotate with @DAO. So we will have three functions here in this DAO. On the one hand, that will be, of course, a function to insert something in the database. So we have a suspend function, insert word info. Well, let's actually insert multiple words here. So infos would be a list of word info. Entity actually, because we're dealing with our database here. And we annotate this with @insert. We can pass an onConflict strategy of onConflict strategy.replace. So if we try to insert an element that has an ID that is already in our database, we will simply replace it. Then what else do we need? We need a function to actually delete all word infos in our database, because that is what we will do when we try to write something into our cache. We will just clear our database and insert our new words, basically to update our existing words. So we just want to have a query where we can pass a list of words, and we will just delete that list of words. I'm not meaning that we delete all words, just that list that we pass. So query, to have a custom query here, delete from word info entity. So we want to delete from this table where the word is in our words list that we pass as a parameter here. So that will be a suspend function, delete word infos, and we pass our words as a list of string. So we just pass a list of strings, for example, bank, Android, and morning. And what this query will do is it will just delete all word info entities related to these words. And we will have one last query here, which is used to actually get a word, to read it from our database in case we want to load that from the cache. So query, select everything from word info entity where the word is alike. And I will explain what that means here after I wrote it. Just type this off here. So we say where the word is like this. So in SQL, these what would be in Kotlin the OR operator. In SQL, that is used to concatenate some words or some strings. And these percentage symbols here just mean that's a placeholder. That could be everything. So we're just searching for our word in our database, basically. That's really what this query will all do and return. So suspend function, get word infos for a specific word, and it will return a list of word info entities. So far, so good. That is it for our word info DAO. The next step and the last, not the last step for our database, but the next step for our database is to set up the actual database class in our local package as well. New Kotlin class called word, let's call it word info database. Select a class here that will be an abstract class. We annotate this with @database to make sure this is our room database. The entities will just be a single entity here, which is our word info entity, ; class, and we need to specify a version, which is just 1 here. So every time you update your database, you need to increase that version. And we need to make sure that this actually inherits from room database. And all we will need in here is an abstract val for our DAO, which is a word info DAO, and room will actually create the rest for us. Okay, so there's actually one last thing we need to do for our database. Maybe you've noticed that already. If we take a look in our word info entity, there is an issue with this class. Because right now we just try to save a list of meanings in our database, but room has no idea how we can actually do that, because we can't naturally save lists in a room database, and especially not lists of a complex data type like meaning. So how can we do that? Well, usually if you want to save a list in an SQL database, that is a sign that you should put the objects that are actually in that list in a separate table here, because that's what relational databases are actually perfect for. But in this case, just for simplicity and for the sake of this video, I don't want to do this because that really makes the stuff complex. If we would have a separate table for meanings and then a separate table for definitions and stuff like that. So what I will instead do is I will directly save the list of meanings in a word info entity by simply parsing it to a type that room understands, and that is simply a string. So we will take this list, convert it to a JSON string in the end, and save it here in our database. And for that, we can create something called a type converter in room, so that if there is a type in room that's not understandable for it, then we can define how we can actually transform that to a type that room actually understands. And for this JSON parsing process, I will actually do something that might not be obvious right away why I do this, but I will explain it after I did it. So actually in our data package here, I will create another util package. And in that util package, I will create a new interface that's called JSON parser. This interface, all this will really contain are 2 functions: to get an object from a JSON string and to parse an object to a JSON string. So function, that will be a generic function from a JSON, which will actually take the JSON string, and it will contain the type we actually want to parse it to. So that will be a type, this one from Java here. And it will then return an object of our type T here. And we will have a function that is actually used to convert something to a JSON string. Here we instead pass our object of type T and also the type. And it will then return a corresponding string. Let's also make this nullable in case something goes wrong there. So let's actually try to understand why I make that interface here. Why don't I just create the type converter and use our JSON instance in there to manually parse these strings from it to JSON? Well, it could happen that at some point in your project you decide that you want to use a different library to parse JSON strings. So right now I will use JSON here because I'm just used to that, but there are so many JSON parsing libraries. There is Marshy, there is Kotlin serialization and stuff like that, Jackson, I think. And if you want to switch that, then you need to change every single spot in your code where you use that dependency. So where you use JSON, where you use Marshy, I don't know, whatever. However, if you have such an interface and everywhere in your code you just use that interface, then that's not necessary, because then only what you need to change is the implementation of that interface, in which you basically tell your code, hey, this is how you use Marshy to convert something from and to JSON. This is how you use JSON to do that, and stuff like that. So in this util package, we will have a class, which is our JSON parser. And that will now implement that interface JSON parser, because every single JSON parser definitely has these two functions. And here we now have that concrete implementation of doing that with JSON. So we actually need a JSON instance for that. Private val JSON of type JSON. And using that instance, we can now simply say return JSON.from JSON. We pass our JSON string. We pass our type. There we go. And here for toJSON, we say return JSON to JSON, and we just pass our object and our type. And now, when we create our type converters, let's do that. Then it will get clearer why we did all this. In our local package, a new Kotlin class called converters. Select class here, and that converters class will now take such a JSON parser. And here we don't specify, is that a JSON parser? Is that a Marshy parser? Because we don't care. This class really only needs to parse something from and to JSON. It doesn't care which library is used for that. And if we would hardcode this here to be a JSON parser, and at some point in our code we decide to use a Marshy parser instead, then at every single point in our code where we use that JSON parser, we would need to go and change that to a Marshy parser. So that's just a lot of changes you need to do if your project grows. If we do it like this, we don't need to do that. Now we just need to define two functions here, basically how we can convert something from a meaning list to a JSON string, and how we can take a JSON string and convert it back to a meanings list. So from meanings list, or rather from meanings JSON, I think, where we get the JSON and we return a list of meanings. So now we just define that for a room. So we're going to return JSON parser from a JSON. The type is an array list of type meaning. And it will now take two parameters. On the one hand, the JSON string, which is just JSON. And the type, this is a bit more complex because, yeah, that's just what we have to do here to define the type of a list, because our list has a generic argument here, and it's not easy to specify the type here. So what we need to do is we need to say object of type token. The type token will be of type array list of meaning, then parentheses, curly braces, and then after that we say type. So that's basically how we handle that. And if that, for whatever reason, returns null, we can simply return an empty list. So let's annotate that as well with type converter to mark this as a type converter function. And then we will have another function to actually take a list of meanings and convert that to JSON. So to meanings JSON, actually a function. It will take our meanings list this time, and we'll return a string. Here we return JSON parser to JSON this time. The object will be meanings, and we need to specify a type. Here we can again take the same type token, paste it here. And if that is actually null, we just want to return an empty list in a JSON format. So this will also be annotated with type converter. And we also want to annotate this class with @provided type converter. The reason why we do this is that we want to provide our own instance of these type converters, because by default type converters can't have constructor arguments like we use here, but we need that JSON parser here, so we need to provide our own converter, which we will later do. So just for room that it actually knows that it shouldn't create that on its own. Now back to our word info database here. We need to pass these type converters using type converters and just saying converters : class. So far so good. That was difficult here for the database stuff, But that is pretty much it for the data layer now. Actually, not really for the data layer, but for our two data sources, our API and database. The actual important stuff that most of you want to see here is yet to come, and that is the caching part, which also obviously belongs in the data layer. So let's see how that works. First of all, I want to paste a class here in our core util package, which is called resource. I use that in every project. Those who actually watch my project playlist know this class. It's just a utility class that is used to distinguish between loading, success, and error states of whatever. It looks super complex. It's actually not. We can just use it when we get an API response to just forward the result to the view model. So the view model actually knows, was that a successful, an unsuccessful response? Are we still loading? Just to update the state. So what will we actually do now? The next step will be to create our repository. And we will actually have the repository definition in our domain package here. So the interface of that repository belongs here in that repository package. Let's do that. Called word info repository interface. And that repository will just need a single function, and that is to get word info. So function get word info. We pass a word, and the return type is a bit more complex. It's actually a flow from Kotlin X coroutines of type resource, of type list, of type word info, our domain word info. Yeah, so we will actually use a flow here to emit multiple values over a period of time. So we can first emit our loading status, then we can get our actual word infos from the cache. We can then make the request. When we get the response, we can emit another list of word infos that we actually got from the API, and so on and so forth. I will explain that more when we get to the implementation now, and that belongs in our data package. So under data, new package called repository, we actually create a Kotlin class, which is word info repository implementation. And that will take two dependencies. On the one hand, our API, which is our dictionary API. And it will contain our DAO, which is our word info DAO. And it will implement the word info repository interface. We can press Ctrl I to implement that single function. And now this is where the caching logic belongs, because that is what a repository is used for and what is the job of a repository. It's used to take all the different data sources you have. In our case, that's API and database. And then it will take that and decide which data should be forwarded to the view model and to the UI. When it comes to caching, you should usually stick to the single source of truth principle. What that means is that all the data that we ever get and display in our UI comes from the database. So we will never get data directly from the API and directly display it in the UI. Instead, what we will do is we get the data from the API and insert it into the database to then show it in our UI from the database. That just makes things a lot easier because we know all the data will always ever only come from the database. So that's just what's called a single source of truth, which you will probably hear quite often if you're dealing with caching. So let's actually start to implement this. We can start by just saying this returns a flow. We use the flow builder here, and in here we can now simply say emit when we want to emit a specific value. So we can say emit resource success, emit resource loading, and then the view model will know about that. So first of all, when we initiate that request, we want to say re-emit resource.loading, because that's what usually should happen when we start a request, that we start to display a progress bar. Now, the next step is that we actually get the first data from our database, so we can directly show word information if we have that in our cache. So we can say val word info, actually word infos, and that is equal to DAO get word infos, And here we need to pass the word we want to get the information for, which is the word we get from the parameters here. And we simply map that to our word info from the model class. So that's also what's the job of the repository, just to map data objects to our domain level objects. Now these are the cache word infos. So if we have some of these, we'd like to now emit these to our UI so we can directly display these, even if we're still loading and waiting for the update from the API. So right afterwards, we can say emit. We're still loading from our API. But this time you can see we can actually attach some kind of data here to that loading. So we can say the data is now word infos. And that will now notify the view model, hey, there is actually word infos to display in our UI now. Then the next step is to actually make the API request and initiate that. We need to do that in a try and catch to just make sure we catch exceptions. On the one hand, we want to catch HTTP exceptions if we get an invalid response. And on the other hand, we want to catch IO exceptions in case something with the parsing went wrong or the server is not reachable or we don't have internet connection. So let's start here in the try block. What do we want to do? We want to get the remote word infos from our API. So we say API get word info and we pass our word. So far so good. So now if we're actually at this point in our code and the request was successful, so it didn't go into one of these catch blocks, we can now actually delete the word infos that we got from the API. We can delete these in our database and update these with the new word infos that we got from the API. So we can say DAO delete word infos, and that takes a list of string. So we can say remote word infos. Since that's a list of word info DTO and not a list of string, we need to simply map that to that word. And right afterwards, we want to insert the new word infos into our database, which is remote word infos.map and it.toWord info. So we simply map that to, it's a word info entity. So we don't want to map this to our domain object. Instead, we would like to have another mapper function here. So we can just say info entity. We want to do that in the DTO class. So remote DTO, word info DTO, and just have another function here to word info entity. And I'm actually not sure if we need this. Seems like we don't. So let's actually just make this the entity mapper and return an entity here. Return an entity here. And that's already it, so we just need to change the names. Because that way we can simply convert it to word info entities and save it in our database correspondingly. If we get errors here, then we simply want to emit a corresponding error resource. So emit resource.error. And we can attach a message. I will just hardcode these here. Typically you would like to use some string resources, but for time reasons, I'm not going to do this. Let's format that a bit. Have a message equal to this. So here we can just say, oops, something went wrong. And we can still attach some data because also in an error case, we got data from our database potentially. So we can say the data is word infos. And we can copy this emit block, paste it here. For IO exceptions, I typically just default the message to couldn't reach server, check your internet connection. And we can also attach these word infos, so we still display something even though we couldn't reach the server. So far so good. So now we made the network request, but there's still something that needs to come afterwards. Because what we did here is just that we got the words from the API and replace them in our database, but we didn't really emit them to our UI. So what we want to do here is we want to say val new word infos is equal to DAO get word infos for our word, and we want to map these to word info objects. So we just read the corresponding words from our database again, and now we can simply emit these, and in that case it's a resource.success, and we pass new word infos. And that's our caching logic here in the end. So quick recap, we first emit loading before we start our database request, and we display the progress bar. We then read the current words from our database, so the cached ones. We emit these with this loading status again. Then we initiate the API call. When we get the result, we simply replace the items in our database with what we got from the API. If we have errors, we simply emit these. And if we don't have any errors, we simply emit the success resource here with the words that we got from our database. So that's now really it for our data layer. The next step is much easier to understand. That's actually in our domain layer, implementing the use case. So we will have a single use case to actually just get a word info. A use case in the end is just a single thing the user can do in your app. That's usually connected to some kind of repository function, but doesn't need to be. In this case it is, and in this case it's a very simple use case. So let's go to domain, use case, create a new class called getWordInfo. And the good thing about use cases is these names that we give them make it really clear what's contained in this class. You don't need to be Albert Einstein to understand what kind of code will be in this use case here. We will just need our repository of type word info repository. And here we will have an operator function invoke. So we override the invoke operator. That's just a fancy thing I like to do, because that way we can call the use case as if it was a function, even though it's actually a class. You will see how that will look like. We need to pass the word here for that use case, and it will just return the same thing our repository returns. So flow from Kotlin coroutines of resource of list of word info. And we want to make sure, so validation logic now goes in here. So we want to make sure if the word is actually blank. So if the user did not enter a word, if we cleaned up our query basically, we just want to return an empty flow. So then we don't want to make an API call. In all other cases, there is not that much to validate here. We just want to return repository, get word info, and pass our word. And boom, that's our use case. It's really that simple. Now what comes next? The next thing will be to write our view model, a word info view model, which will basically just call this use case. The view models will always call your use cases and then forward the result to your UI. So it will take the result from the use cases, map it to corresponding compose state, and provide that for the UI. View models belong to the presentation layer, so let's put it in here. New Kotlin class called word info view model, and select file. I have a fancy shortcut here, hill view model. You need to type this by hand. And that will be called word info view model. Then we will inject dependencies here using degreed. In this case, it's just our use case. So val get word info of type get word info. We will have the degreed set up later when we create the view model. So then we will be able to inject that here. Then what I like to do is to create a state class here for each screen that just displays, or that just kind of is a wrapper class for the state variables that are relevant for the UI on that screen. So in the presentation layer here as well, we'd like to create a new Kotlin class called word info state data class, and that will here just contain two variables or objects. On the one hand, it will contain our word info items, which is a list of word info defaulted to an empty list, and we have a boolean if we're currently loading something, and that's false by default. So now we can use this wrapper class in our view model to provide some state for our UI. First of all, which states do we need? On the one hand, we need a state for the actual search field. I like to decouple that from the states wrapper class because that changes so frequently. And if we always update the states wrapper class, we would, basically update our whole UI every time we have a keystroke on the edit text. So that's why I simply like to have a separate state. I also have a shortcut for that. You probably also need to type that by hand, which is called search query. Is a string, and initially it's an empty string. So we just expose the the immutable state here of compose to the UI. So the UI shouldn't be able to modify this. That's why this is private and this is public. And we'll have another one of these for the word info state, or I'll just call it state because that's the main state of this view model. Word info state, and initialized with an empty word info state. Just like this. And one more thing we actually have is a so-called event flow. The event flow will be used to send one-time events to the UI, like showing a snack bar for an error, for example. So for that, we can simply create our own UI event class. I like to make that a sealed class, like this. And in here, we can have different types of UI events. We will just have a single one to show snack bar. We will have a message here for that snack bar, and that will just be of type UI event. Then we can create such a flow that will be a shared flow to send these events. Private val event flow is a mutable shared flow of type UI events. And we have a public version of that event flow as shared flow, just like that. And then we need a function on search when we actually type something into our text field. So every single time we type a character, we will trigger this function. And it will make a corresponding query to our API and database to get the results from the cache. However, I'd like to have some kind of delay after we type the character, so we wait like half a second before we actually make the request, because usually you need some time to type a word, and we don't need to make a request for every single part of a word, basically. So that's why I will introduce a so-called search job here, which is a coroutine job, null initially. So with that coroutine, we will basically make use of that to cancel that when we actually type another character. So you'll see how that works. I don't want to explain that right now because it makes more sense when we type that first. So first of all, we of course want to say search query value is query. We just want to update the search state in our UI. Then we want to say search job.cancel. So we cancel the current search when we type the new character. And then we say search job is equal to viewModelScope.launch. So we launch a new job inside of that search job, in which we now execute that request. So we first want to delay that for 500 milliseconds. And here I'm hard-coding this. You should rather make it a constant for time reasons. I'm not doing that here. So 500 seconds, we actually delay until we start to make the request. If within these 500 milliseconds we type another character, this function will be called again and it will cancel the old running job and wait another 500 milliseconds until there will be 500 milliseconds in which we did not type a new character. Then we will execute the actual search. So now in here, we will now call our use case getWordInfo. That's a class, but since we overrided the operator function, we can simply call it like that, like a function. We want to pass the query as the word, and that now returns a flow. So we can call on each to listen to every single emission, which is now a resource of a list of word infos. So we can easily now check what kind of result we got here. So if that was successful, if that was an error from our resource here, or if that is loading. Now the job of the view model is to just deal with these cases and map the result to our state accordingly. So we can say state.value is state.value.copy. And here in the success case, we just want to swap out the word info items with result.data, which is also of type word info items, or an empty list if we don't have that. And is loading is simply false. And that's actually what we want to do in pretty much all of these cases, because also when we get an error, we have results, we maybe have results from our database that we want to show. So just like this, is loading is false, and additionally we want to show a snack bar, so we take our event flow and emit that. We want to emit a show snack bar event, and we can attach a message that probably just says result.message, and if that's null, we say unknown error. So you could also spend a lot more time with this error handling here. I don't want to do that here. However, for the last part here, I can paste this again. And this is basically, yeah, here we want to say true, because when we're loading, then we obviously want to set is loading to true. But we also might have some data to actually display. But that's pretty much it for this on each here. Right now, nothing would happen because we also would need to launch this flow, which we will do after on each. So here we can say launch in, and we pass this. So that just refers to the current view model scope here. Okay, and that is actually it for our view model. Now what's missing is our Dagger Hill setup, dependency injection, and our UI, which is really not that complex. So let's actually start with Dagger Hill. So here in our root package, we'll create an application class which is needed for Dagger Hill called dictionary app, which is super simple. We'll inherit from application, and we annotate this with Hilt Android app. Then the next step is to actually register that application class in our manifest. So let's open that. Go inside of the application tag and specify name dictionary app. When we're already here, let's also add internet permission, users permission, internet. And we only need one more thing for Dagger Hill, and that is a module in which we provide the dependencies that we actually want to be able to inject. So let's go to DI and create a new Kotlin class of file that will be an object called word_info_module. I also will go through this a little quicker and assume you know Dagger Hill from my other videos, because this course is more about clean architecture. So I'll annotate this with a module and install in. We install this in singleton component. So all of these dependencies will be singletons. And now we need to think about which dependencies we actually need to inject. Well, we can actually start with the dependencies we need in our view model. And that's just the use case. So let's start to provide that. Provides and singleton function provide get word info use case, and that returns a get word info use case here. So we can say return get word info, and oh, here we need the repository. So let's simply provide that here. Word info repository, pass it for the use case. So the next thing we need to provide is the repository. So the next function is provides singleton provide word info repository, and that returns a word info repository, where we simply return word info repository implementation this time. And ooh, we need our API and our DAO. So let's simply pass these values here. Word info DAO, and our API is our dictionary API. So API and DAO. So these two are the next things we need to provide. Provides singleton provide. Actually, let's provide our database. So provide word info database. For that, we need our application context, so we can just pass our application, which Dagger Hill will automatically pass here, and that will return a word info database. We can say return room database builder. The context will be app. The class will be word info database.class.java. And the name will be word db maybe. I don't know. Choose whatever you like. And we can call that build. Let's also change that up here. So not injecting our DAO, instead our db, word info database. And then we can say db.dao here. So that way we're just a little bit more flexible if we have the database and if we're able to inject that instead of saying that DAO here. And one last thing is retrofit. So provides singleton function provide dictionary API. That does not take any parameters, I think. So dictionary API. Return retrofit.builder.base URL. We actually don't have that yet, so let's go to dictionary API in our data package. And in here I will have a companion object with our base URL, and that will be https api.dictionary api.dev. So then we go back to word info module, specify the base URL is dictionary API base URL, add converter factory, and that will be JSON converter factory dot create, and we can call create or build first, yeah, build first, and then dot create, passing our dictionary API class.java. One thing we forgot and that we also need to provide is actually our type converter, because as I said, we manually need to provide that for Room. So here in that provide database function, we actually want to add a type converter. And yeah, in here we can simply pass a JSON type converter, a JSON parser actually, with a JSON instance. So typically I would also have my own provides functions for these here and pass these as values. But since we don't do anything else with that, I'll just create it in here. And now if you decide to swap that out with Moshi, all you really need to do is to pass a Moshi parser here, or wherever you basically inject your dependencies. So I think this is it for this module. So the really last thing we want to do here is to implement our UI. And that's luckily not too complex. I will put all of that in main activity. Actually, we want to annotate this with Android entry point. And yeah, as we don't have any navigation here or multiple screens and stuff like that, I'll just put everything in here. It's not too much code. If you want to learn how you can build multi-screen UIs, then check my other videos. This here is not about UI. First of all, let's get a reference to our view model. So val view model is equal to hild view model. It's actually of type word info view model. Then we want to get a reference to our state that we get from the view model. And we will have a scaffold state. So a scaffold will be needed to show snack bars easily in Compose. Remember scaffold state. Okay, so far so good. Let's start with a launched effect block passing true for the key. This will be needed to actually listen to these events from the event flow we actually have in our view model. So in here we can say view model, view model.event flow collect latest. And we can collect all of these events in that launched effect block. So when that event is actually show snack bar, then we want to show a snack bar. It's really that easy. So we can say scaffold state dot snack bar host state show snack bar, and the message is event.message. So that's how we can easily show snack bars in Compose as in form of an event that we get from the view models. So after this launch effect block, our UI will now start. So let's start by wrapping everything into a big scaffold. Actually, we don't want to pass a modifier. We can just pass the scaffold state here. And then in that, we will actually put our UI. First of all, let's have a box where we pass a modifier of a modifier from compose. That background, we fill that background with material theme, colors background. You can also put that into its own line. And then in that box, we will have a column. For that column, we can say modifier, fill max size, and we want to add some padding of 16 dp. Import dp here, pressing Alt plus enter. And okay, what will we put inside of this column? In the end, if we take a look here in our app, then the column will contain this text field here, and then it will contain a little bit of space and the lazy list for all of these words here. So just text field space lazy list. So we can start text field. And I will keep this very, very simple in terms of styling. Let's format that a bit. The value will be view model search query value, and on value change is view model : on search. Modifier can be set to modifier fill max width. And we want to make sure to pass a placeholder that just says, or that just displays a text rather, that says search. Just like this. That's already it for this text field. Then we'll have a spacer with a little bit of height, 16 dp, and below the spacer, as I said, we will have our lazy column. That is basically just the list of items we want to display. So here we also make sure to fill the whole size, modifier fill max size, and then in here we will have an items block for every single item in our state. So state word info items.size. We get the current index here, and then we can get the corresponding word info with that. So val word info is equal to state word info items at the index of I. If this index is greater than 0, so for every single item except for the first one, I'd like to add a little bit of extra space, so height 8 dp. This will basically just make sure that after a word is over, we have a little bit of space here. Then after that if condition, we will have a composable that we will create, a word info item, where we can just pass the word info for that, or let's call it word info as well here. We need to create that. And after that, I can check again and make sure if I is actually less than state word info items.size -1. So all that really checks for is if we're not at the last item. So basically for every single item except for the last one, we just want to add a divider. So that way we have these little lines between items, but basically not here for the very last one. So let's quickly create this word info item, and then we're already done. I mean, already took quite a while here, but I'm sure you've learned a lot of stuff. Let's go to presentation, a new word info item. Will be a file, and we can create a composable here called word info item, and that will take the word info in form of a word info item. Actually just in form of word info. So now we're basically creating the composable for such a word. So word, phonetic, description, type of word, example, stuff like that. Just a bunch of text. So we will start with a column. We will pass a modifier here, which I also want to pass here. Compose modifier is equal to the default one. And inside of that column, we first want to have a text for the actual word. So the text is word info.word. We can set the font size to something like 24 SP. Import SP. We can set the font weight to bold. And we can set the color to color.black. That's it for the title. The next would be for the phonetic. So yeah, let's set the text to word info.phonetic, and we can set the font weight to light for this. So that way we get this, yeah, it just a little bit lighter and looks good in my opinion. We can add a little bit of space here of 16 dp height. Also import dp. We then want to have another text for the actual origin, so word info.origin. We don't need to change anything else here for this origin. And then all we really want to do for the rest is we want to loop over the meanings. So word info meanings for each. It's actually a lot less work than it looks like in the UI. Here we get the meaning. Let's first start with the meaning dot part of speech and also make that in bold. So font weight is bold. Then we want to display all definitions of that meaning. So meaning dot definitions for each index actually, because here we also need that index to display some composables correspondingly based on that. So now we will basically just display here basically everything that comes after noun here. We want to iterate through this list and yeah, basically numerize this. So 1, 2, 3, 4. That's why we have that index. And just display the corresponding definition together with the example. So we will have a text that says index plus 1. Now let's actually call it I plus 1, a dot, and then we simply use, oops, definition dot definition. So that's it for the definition already. We add a little bit of spacer. Let's say height 8 dp. Actually modifier dot height. Then we have some extra text that is for the example. So definition dot example. And that's nullable. So let's actually make a null check here. Definition example dot let. We get the example here. And then we can put this in there. So yeah, just let's replace that with example. And let's actually also say example is example. Just like this. Then after that, let's have a little bit of spacer again. ATP height. Ah, come on. Height, this one, it's not including the modifier. Modifier height 8 dp. We can copy this line and just have that one more time after this for each block, this time with 16 dp. And that's it for the word info item. So going back to main activity, we simply need to import this. And I think this should be it. We will see, maybe I missed something, which is very likely in such a rather long video. But I think we are ready to actually click run and wait for this to launch. Okay, so the very likely thing happened. We actually have an error here in our project, which is, I think, easy to fix. A required type converter for blah 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 was expected. So our room database basically doesn't recognize our type converter. Let's take a look what that is in our word info module. And yep, that is a silly mistake I actually did. We don't want to pass our JSON parser here. We of course want to pass our type converter. So converters of type, actually not of type, just the converters with our JSON parser and our JSON instance. So with that change, let's actually try to run this again. And hopefully we don't get another error. Installing. And this time it does not crash, which is good. One thing I actually now realize I forgot is the progress bar, but I don't think it matters here. Just have an if condition. If state is loading, show progress bar. It's really easy. Let's try if we can actually get a word from our API. Let's search for Windows, for example. And we couldn't reach server. Yeah, which is expected because I'm still in airplane mode. Let's disable that then. And once we connect here, probably already, let's update this. And yeah, we do get the word window from our API. Let's also search for other words, bank, as I said, to check if we get multiples. Yep, we get multiple bank words. we can search for basically anything, Android, iOS. I don't know if we find that. Oh, it even finds iOS. Yeah, so that's pretty cool. And let's test the caching. If we close that app, go to airplane mode, and we open the dictionary again, and we now enter iOS, then we actually load that from our cache. So that is working perfectly fine. We can do that with Android, basically with everything we've requested in the past, and bang, obviously. So these words, and that's just working perfectly fine. The snack bars are appearing. And yeah, just for the progress bar, let's quickly do that. Main activity. Here in our box, we want to make sure that if the state is loading, we want to show a circular progress indicator. It's that easy. We can relaunch this, and then we will see that we can actually also see the progress bar in our app. So here, if we now search for car, maybe, yeah, it's not aligned properly. We would need to center it. But the progress bar, it appears. To align it, we can say modifier is modifier align and say center. I'm not going to relaunch that now because I think you get how that works. So yeah, congrats for actually finishing this rather long video here. In case you enjoyed watching this video and you liked what you learned and you actually learned a lot, then you will also learn even more by subscribing to my free email newsletter in this video's description. So simply enter your email, it's totally free, and you'll get regular advice on Android, Kotlin architecture on a weekly basis for free. It's basically like a blog. Also, I would be very happy about a like and a comment down below, just telling me how you like this video, if there's something I can improve on, because these types of videos are a lot of work, and yeah, it would be cool if that somehow pushes the YouTube algorithm a little bit, so even more people can benefit from these videos and learn how they can actually properly do Android development. Thanks a lot for watching, and I'll see you back in the next video. Have an excellent day. Bye bye.